So this is actually what we're going to create today. It's just a basic building system where we can actually highlight blocks and of course delete them. And all of this is of course also stored in a parent. Hello guys, and welcome to a short tutorial on how to implement a Minecraft-esque build mechanic into your game. And to be honest, it's really quite simple and this tutorial should be quite short. So let's actually already begin by just creating a small C# script. Let's call this like build system. And let's open that up in the code editor. Now, how this build system is going to work, I might actually just demonstrate it right here, is that we're going to have our player here. Yep, I know my art is wonderful. And let's say we have our ground here. Well, we want to just raycast from the eye of the player to like a point on the ground. This point, however, is going to be quite varied. Like, I mean, the points we're going to get here are like 1.5 and 2 maybe. That this point might be 1.7 and 2. This is not what we want. We would create blocks that would like be in each other. Therefore, we round these values up to an integer, meaning that we should get even spaced blocks along this axis here. And we also want to, if we actually hit a block that's already there, let's say our player here hits a block here, we actually want to get the face here of that block and place a block adjacent to this one. Now this all sounds really complicated, I know. However, it's really simple to do like in Unity. So let's open it up and let's just make a quick function to place a block down on a raycast. Let's just put a game object here, block. So here, boom, and make a public game object for our block object. Now, and we can also do a void update and gather the input data of our mouse. Mouse button down 0. This means that we're going to get down 0, and let's just do a build block, boom, block object. Okay, this just means that whenever we press the left mouse button, this function is going to be run. Now what we want to do here is there's a quite good function in Unity, the here the Raycast function. You just have to physics hit. No, Raycast hit, sorry. Raycast hit. This object stores the information, and sorry, I did that wrong. We actually want to just raycast the raycast from one point of our player here to another. However, we can't just do this from a camera that's inside of the player, because this would actually, if we look at a player model I have here in Unity, by the way, this project has nothing more than a default FPS controller, and yeah, that's basically it's just a basic player. So if we would just right now raycast from the center here, this main camera, and by the way, this, I don't know if I said it already, this player controller is from the Bracky's video on basic player controller. So if we go into the camera here and would just raycast from here down to the floor, it would actually collide with the collider of this bean, meaning that we would actually have to have a point outside of the bean, like a shooting point, where we should start the raycast. I already did this here, so just go into, if I just delete this, just go into main camera, create empty, let's call this shooting point, and let's just move this out of the bean so it does not collide with the collider here. Nice. And we should of course make this public transform, sorry from a bad typing, and let's just call it shooting point. Now, for the raycast to actually take effect, you have to define a position where it starts, then a position where it goes, meaning a direction, then just out raycast hit info, and then let's just put this in brackets, put a if in front of it. Sorry, I'm going to explain all of this right now, and just debug.log hit.transform.name. I'm just going to explain this now. Okay, so the if in front of this, this actually returns a bool if it actually hit anything, meaning this won't run if we don't hit anything, which is of course a good idea as it's like safe performance, and we don't want to do anything if we obviously don't hit anything. Now, what we do is we start at this shooting point position, meaning here. We go into the forward direction with this blue arrow here. Also, this is, by the way, under this camera, as when the camera moves, this shooting point actually also, if we just go to the local thing, also moves, which we obviously want, as we want to build in this direction we look. Okay, so, oh sorry, just opened OBS. So yeah, shooting point dot forward, meaning the direction this raycast will go, and it just outputs into a raycast hit info, meaning this is like a lot of info we get from this raycast. Now, we actually want to do something with this info, and we want to spawn a block. And as I already stated, we want this block to have rounded position numbers, as it would create very bad stuff if we don't. So, let's just make a new vector 3, let's call this spawn position, and let's set this to a new vector 3. mathf.round, round to end, and then we can do this hit info dot point dot x. This is the impact point of this hit info. This hit info dot point is just the point where it impacts, and this is just the x variable of that vector 3. So let's just copy this 2 more times. And instead of x, y, and z. Nice. So now we can actually already instantiate a game object. Let's just set this to the block we specified in this function up there, then the spawn position, and we do not want to mess with its rotation, so we just set the quaternion to identity, meaning 0. And if we just run this, we should actually see that it's already working. Let's just add this component here. Define the shooting point. And cube, this is just a very basic cube. I just create cube, bam. Remember to set this transform to the 0, 0, 0. Drag it down here. Yeah, sure, delete it. Bam, delete off the hierarchy, and now you have this quite wonderful cube down here. I know, Minecraft quality. Boom, bam. Remember to always save your scene. Let's run the game. As you can see, we can now already place blocks. However, what you will soon notice is that if you actually click on the same position over and over again, it actually spawns it again inside of this cube, as it actually just takes this point from up here, round it down to well, the same position as this block has, and we then get it's just not a nice system. So let's fix this, and also here is really nice and easy way to do this. And let's just first yeah, sure, I'm going to go into paint again and explain a bit. So every 3D object here actually has a face. That's just these things here. And we can get the face we actually hit just now by using the hit info. Let's just put it here. Here. Hit info dot normal. This returns the face of the object we just hit, and we can actually just show this to you by putting this in a debug.log method, meaning it's going to be outputted into the console. Boom. And let's just place a default block in here. Give it a bit of height. Nice. And what you're going to see is that when actually like pressing on this, when looking in the console, it gives us the vector 3 of the thing we have just hit. See here. And we can actually just use this to offset the position of our block. However, we actually have to know that we hit a cube. And for that, I would just, out of simplicity, I'm sure there's a better option for it. However, out of simplicity, I would just add a tag to this cube called block. I already made one. If you don't know how to add tags, just click on add tag on this plus here, and just rename it to like block whatever. Click on this cube again, tag, and now you're going to see your new created tag here. Okay, just remember what you assigned it to here, because now we have to go into the script and just check if what we hit was a block. So if hit.info.transform, meaning the object we hit, the tag equals block, meaning we did actually hit a block. We do not want to instantiate one at this position. Let's just put else here. Nice. We want to offset it by the block we hit, and we do that actually quite similarly. And we can actually put this out of this function here, as we not, I guess. Here. No. So what we want to do is actually offset every axis by the hit info dot normal dot x y and z value we get from the block we just hit. And yeah, it's actually that easy. However, as you're going to see, it's still not quite right. However, that's a problem you might actually not have, so that's why I'm just showing this to you right now. Meaning, if we just place a block here, you can still see it just this weird stuff. And let's just check I didn't put an error in my code. Hit that. Oh, of course, I just... Please remember to put the x, y, and z coordinates in the back of here, x and y, meaning we actually offset by hit info normal x, normal y, normal z. Okay, sorry, my mistake. No. However, if we look into this now, you can actually see that it offsets it by one block too many, meaning that if we look into these positions, it does actually update it by one total, in one entire thing. However, that's not what we want. We want to have the half of that, meaning we just go into this code here, and after this hit.normal.x, we just put it by 2, or divide it by 2, meaning that we also decrease the range this block basically spawns from the block we hit. Yeah. So if we just check it out now, we can actually see that if my mouse would actually be here, nice, spawn them where we want. And to be honest, this is your basic build system. However, we can actually just improve this massively by adding 2 steps. The first being destruction of the blocks we actually hit. That's obvious, I know. So let's just make that, and it's also really easy. If you've understood everything until now, void just destroy block, let's just do another raycast. Now here. And just say destroy hit info dot transform dot game object. And that's it. At least for this function. And I'm just going to here, go back up here and set it to if input dot get mouse button down 1. Destroy block. Nice. So what does it do? If we get the right mouse button, that's the one here. Like if someone presses it, this is by the way update loop, meaning it runs quite a lot of times per second. Actually your frame rate, like if you have 60 FPS, it tracks 60 times a second. So we check if you press the right button. If so, we do a raycast from our shooting point position, shooting point forward, and actually what I just did was quite wrong, and we would get quite a bit of trouble doing this, as right now what we're doing is destroying anything we touch with this. Meaning, let's say you have a big world and have some rocks or foliage in there, we would actually destroy it by just using this option, meaning we should actually check if it's a block we're targeting. Meaning, let's put an if statement in front of it, put some brackets there, and just put in there, meaning now it's actually a block we're targeting and we're not just destroying random stuff. And if we put it into the game and just check, we can see here that when I right click right now, nothing happens, and boom, yeah, nothing happens. And if I just look at a block, I can actually delete them. Nice. Okay, nice. And now the final and last thing is actually the highlighting of blocks, meaning something that Minecraft often does is just when you look at a block, you highlight the block. And this is also comparably quite easy to do. I actually did get quite a lot of errors just testing this out, however it's easy once you understand the basic principle of it. Let's just call it highlight block. Here. You could, by the way, just do all of this, just paste it in here, and do all of this and just paste it in here. However, doing it in functions is just much more clearer, and I just highly recommend make clear code for other developers to understand, because there's nothing worse than trying to understand someone else's code. Okay, let's go back to the highlight block. We actually need a game object, new game object. It's going to be private, called last highlighted. And I'm going to explain what it does right now. So basically how this highlighting is going to work. Can I just... I'm just make a new one. Don't save. Okay. So basically how this highlighting is going to work. We're going to look at a block, okay? Yeah, I know. Here, bam, bam. This is you, here. So basically you're going to look at a block. And if it's a... First of all, we're going to register, is it the block you're looking at? If so, then... basically put a new color onto it. Wow, I just chose the completely worst color. Here. So just mark it here. Now, let's say you look at another block. Boom. So you change your... we raycast and we change it to here. Where we want to do the previous block, we want to make it to its original color. Like that, and we want this block to then be highlighted, and vice versa. Next thing, boom, your vision changes again. This thing should be its original color, and then this should be highlighted. So what we have right now is just the last highlighted block, and this is just checking if if we have a new block, like meaning if the current block is not like this last highlighted block, and if so, change it. And let's implement that by just again copying this raycast. Then, very important, let's close this bracket on here. Let's check if our hit info is actually a block, so if we did actually just hit a block. And if so, we want to check if our last highlighted block does not equal to this hit info dot transform dot game object. Boom. And let's just say that last highlighted block equals hits info dot transform dot game object. Now, why this not equals? I hope you understood from this previous explanation. So basically, just if the last highlighted block, meaning the block we were looking previously, is not equal to the one we're looking at now, i.e. we're looking at a new block, well, the last highlighted block should be this block we're looking at right now. Okay, so now we actually want to change the color of this block, and through that we can actually do it also quite simply. We just have to exclude two other variables, and those are going to be a public color, let's just call it this normal color, and a public color highlighted color. Nice. Now let's just drag it down here, and this again should be quite forward. It's just a very long line of code that's just there to do one thing, and that's to change the color of the material of the block we're looking at. To that, just go to the last. We just want to do the last highlighted block should be a new color, meaning dot get component renderer. Sorry. Here, the renderer is just this thing down here. Dot material dot color. Oh, sorry, it's not actually this thing down here. It is this thing here. Now we're currently going into this material thing, this lid shader. This lid shader is what's down here. We're basically going into it, and now we can access the color of this lid shader. This field here, dot color equals normal color. Normal color, nice. Now, and the hit info dot transform dot game object from the current block we're looking at, we should get the component renderer dot material dot color equals highlighted color. Nice. Okay, so what are we going to do? Well, the last highlighted block, meaning the block we're not looking at anymore, is going to get the normal color again, and the block we're currently looking at has to have the highlighted color. Nice. So let's go back into here. I'm just going to copy this default color of mine. It's just right click, copy. If you don't see this right now, it's probably because you haven't clicked on here, this little box on here. Let's go to our player, and let's on the normal color, and just paste it down there. I'm just going to paste on the highlight color again, and just make this highlight color like much brighter. And of course we have to put this highlighted block method in our update loop. I'm just going to put it here, so it checks like every frame if we're looking at a block. And let's just try it out. So we can still place blocks. We got an error. Let's just check. Object reference not set to an instance of an object. Last highlighted block dot get component renderer. Oh, of course. So what just happened? As we actually have this last highlighted block up here, and it's just a private game object that's basically null right now. We can't change the color of a null game object. Meaning, or basically we're just checking a null game object equals to this, which we just can't do. So it's just if a last highlighted block equals null, let's just do last highlighted block equals hit info dot transform dot game object, and let's just change its color to this highlighted color. Why? Meaning that if we just look at a block right now, we can save it as the last highlighted block, and we can highlight its color. And this thing right here should be a else if. Now let's try it out. And now if we just get my mouse into here, we can actually see that we can now place blocks, we can destroy blocks, and we now have a really nice highlighted effect on them, which I think just increases it like by 100%. It just looks so much cleaner right now. And yeah, that would be it. I would highly recommend to make a parent object for all of these blocks in here. I don't know what's up with my movement controller. I guess I'm just going in that direction. So I would highly recommend just making a parent object, like a block parent in here, just assigning these blocks you create here to them. It's also really simple. Just make it like a public transform parent, and just parent these objects to them. Nice. And as you can see, we obviously have to assign this parent here. Come on, go down. Nice. Here. Nice. Just save all the time. Just save the most often you can. Saving is your best friend in game development, believe me. Okay, so now if we just place a lot of blocks, it doesn't just clutter our inspector. And we can see here, if we just make this bigger, all of these blocks are in here. Nice. So that's actually the end of this tutorial. If you would like to see more on this subject, something similar, I could also make a actually block palette, so you can have like scroll through different types of blocks. Yeah, I could do a tutorial on that. It's not that hard, I hope. Yeah, I hope you enjoyed, and well, have a good day. And please leave feedback in the comments for anything I could improve upon. Yeah, bye.